Okay, so we're going to look next at the position of points relative to the circle. So to some extent, this comes back to what we were talking about the equation of the circle. And we have our two different equations. I suppose we're particularly maybe looking at, say, that first one, for example, so the x minus h, y minus k squared one, and the idea that that's very related then to just our overall distance formula. So in theory then, when I sub points into that formula, I want the end result to be the radius, because the formula really is just calculating the distance between those points, and the end result then is radius squared, because we've eliminated that square root from the distance formula. So that's kind of the same idea that we're following here, and kind of similar to really the equation of a line and what we do with the equation of a line. So when we want to show that a point is on a line, we sub the point in and it should satisfy the equation. And the same thing's going to happen here. If we want to show that a point is on the circle, we sub the point into the equation of the circle. And if it satisfies it, if it works out, then that means the point is definitely on the circle. What we can do, I suppose, with a circle that's different to a line is we can actually consider where the point is relative to the circle as well. So if I was to sub my point into the equation in either format of the circle and to end up with a result that is less than the right hand side, okay, which could be the radius, which could be 0, that's going to show that my point must be inside the circle. And similarly then, if I end up with a result that's bigger than the right hand side, then my point must be outside the circle. So really this table that we have in the center here is kind of your key point for this section, really, for looking at where is a point relative to the circle there. And it's all really coming back to the distance between those points and the center of my circle. That's really what it all comes back down to. So looking at this then in practice, let's investigate whether the point 0, 5 is on, inside or outside the circle. So into this circle, I'm just going to plug this point in and I'm going to see where it leaves me with, and then we'll make some kind of deductions then based on the result that we get at the end. So I have 3 squared plus 4 squared equals 25, 9 plus 16 equals 25, and I get 25 equals 25. So because it's exactly equal, that's going to tell me that the point 0, 5 is on the circle. Okay, because I've ended up with something that is exactly equal, that must mean that my point is on the circle. If we try on the right hand side here then, this other example, so show, investigate, same again, where the point is relative to the circle. This time I have, I suppose, more places that I need to sub this in now because we're using that longer format of the equation, but the overall end result is the same. I'm going to look at the end result that I get on, I suppose, the right hand side here and compare it with the overall end result that I have on the other side. So 16 plus 9 minus 16 minus 18 minus 3 equals 0, and I'm going to end up with minus 9 minus 3 minus 12, which is less than 0. So that's going to tell me that my point 4 minus 3 must be inside my circle. Okay, so from that I'm deducing that my point 4 minus 3 is inside my circle. Okay, and obviously it's a little harder here in this kind of right hand side format to really relate that idea, but it comes back to the same idea that we have with our line there. When I sub the point in, if it directly satisfies the equation, then it's on the circle. If it's less than what I want on the right hand side, then it's inside the circle. If it's greater than that, then it's outside the circle. And again, it's more to do with really where we got the origin of that kind of simpler or more kind of reduced equation of the circle, and how we use that then to just expand those brackets to get that long form version. So really both of them originate from that kind of equation of the circle format there, I suppose. So looking at these exam questions then, is the point 11, 10 on, inside or outside the circle? Okay, so let's have a little look. So we're just going to be subbing in now. Obviously this, as it says here, is an ordinary level exam question, because unfortunately for us, this is not necessarily something that is all that tested at a higher level. It's still important to be aware of. So 49 plus 144 equals 169, and I'm getting 193, which of course is bigger than 169, so therefore my point is outside the circle. Okay, so therefore my point is outside the circle. Okay, and just as straightforward as that. Looking at the next example, then the point minus 2k is on the circle. So when I see that it's on the circle, I know that if I sub in that point, it's going to satisfy the equation. They're asking me to find the two possible values of k. So let's just sub in my format here. So minus 2 squared plus k minus 3 squared equals 65. Minus 4 squared plus k minus 3 squared equals 65. 16 plus k squared minus 6k plus 9 equals 65. And let's just simplify all of this down to bring everything to the one side here. So 16 plus 9 minus 65 is giving me minus 40 there. So minus 40 equals to 0. Okay, solving my quadratic there then is going to give me two answers for k, which is exactly what we wanted here. They said there were two possible values, so I was kind of predicting at some point we would have a quadratic then. So I get two answers for k, which are k equals 10 and k equals minus 4. I wasn't asked to find the equations of the circle here, or to find that, I suppose, to lay out my points. I was just asked to find the value of k, but maybe we'll just kind of write down the 2 points then that could be that they could be talking about there. So 2 points, both on the circle with different y values, but both with an x value of minus 2. Okay, and kind of worth noting even there as well that really on this circle, as it happens, the center here actually is, the center is 2, 3. So my points of minus 2, 4, we're probably looking at, say, something like maybe 2 points there that are kind of just directly above each other. The last one then that we can look at here really is again to do with making use of what we know about when a point lies on a circle. So they're saying find the values of t for which this point lies on the circle. So if it lies on the circle, it will satisfy the equation. So I can simply, looking at what's ahead of us, we're going to sub these values in. Okay, something as simple as this is just writing down the equation, subbing those values in is going to at least definitely get us some marks, because we're showing that we're setting off in the right direction here. So I'm going to square here. Squaring means squaring the top and bottom of my fraction here. I'm going to hold off on multiplying out the bottom part here because I just foresee that being a little involved. So I'm just going to hold off until I see exactly where the question is taking me here. I'm just going to multiply across by this bottom part that we have here, the 1 plus t squared, because I can see it is the denominator of both fractions there, so that's going to eliminate that denominator altogether. And it's going to mean that I'm still left with this 1 plus t squared all squared here, but equal to 1 plus t squared squared. Okay, on the right hand side here. So now we need to expand our brackets. And on the right hand side, same thing again, 2t squared plus t to the power of 4. Okay, we're going to see where all of this takes us now. I can see that my t to the power of 4, because it's on both sides, is hopefully going to kind of cancel each other out here a little bit. But let's bring everything over to one side and see where that leaves us. So I have now 2t squared, tidying this up here, plus 1 plus t to the power of 4 minus 1 minus 2t squared minus t to the power of 4. Okay, and equal to the circle. Okay, equal to 0. And what I have on the left hand side here is just going to cancel out with what I have on the right hand side here, and we end up with an answer of 0. And that shows us then that the point is on the circle for all values of t, which is what we wanted to show. So no matter what t is, that point is still going to be on the circle. Okay, so we weren't actually asked to find out what t is, we're just asked to show that no matter what t is, that point is going to be on the circle. So just a matter of subbing it in and using what we know about a point being on the circle there. So really the main thing that's coming out of this section is just that yellow box that we've highlighted here, and making sure that you're aware of that and what it means for the position of different points relative to your circle, because that's going to be quite important then as you work through some of the other questions here.